Yeah. Okay. Good. So, yeah, as I was introduced, we produce an electronic lab notebook, and what I'm going to talk about is kind of where an electronic lab notebook can fit in the whole process from doing research through to publishing. And as you'll see, we think it can play a pretty key role. Does this have a pointer, by the way? Okay, great. Okay, so I'm going to start by just sort of reviewing what are the drivers for this growing focus that we have on research data. So one of them is that the data sets have become research objects of interest. They're sort of first-class research objects, whereas traditionally the data that underlies a publication wouldn't have been released or made available, maybe only to collaborators or to people who specifically request it. The journal article is the primary object, and it contains some sort of summaries of the data. That's kind of the old model, the traditional model that's been going on for hundreds of years, and this is changing now. So data is becoming more of a primary object. So data sets are now quite often citable in their own right. And there's this increased focus on reproducibility that we've heard about earlier this morning. That means that scientists, the public, journalists want to be able to look at the primary data to have some sort of check that the conclusions in the publication are actually valid. So another part of this is that funders are for a while now, they've been making statements around making data public. So for example, the Engineering Physical Sciences Research Council, which I get funding from, now requires that if any publication that you make that relies on their funding, you have to provide a statement in the publication of where the data can be obtained from, or if it can't be for some reason, why not? And there are good reasons, privacy and so on, for personal data. I mean, this actually goes back quite a long way, and in fact, one of the drivers for the establishment of this company back in 2002 was that the National Institutes of Health issued a statement saying they were going to require all of their grantees to make their data public. And so at that point, we thought, well, if people are going to make their data public, they're going to need it to be organized, and so they're going to need electronic tools to do that, and that's how kind of we got started. It turns out that that statement didn't get backed up for quite a long time, but we've got to the point now where funders are actually really demanding this. And that the funders demanding it means that institutions are now moving to respond to that demand by funders. Publishers, as we've heard a lot this morning, are trying to accommodate this, and they're trying to provide methods to link primary data to the publication. And then, as we've seen this morning with Science Matters, and there are other examples, there's now the development of publication mechanisms and platforms that are more focused on the data itself. So these are all kind of aspects of this growing focus on research data. So from our perspective, looking at this, what we see is that the kind of initial response to this has been data repositories of one kind or another. So the older repositories that traditionally were there to provide access to publications are now starting to allow for depositing data as well as publications. And there are examples of this kind of thing. And then there are new repositories that are focused primarily on data. And they're trying to provide ways of accessing and making use of that data after the deposit. And then, as I said, the institutions are more interested in getting now than they were in getting data into repositories. So most of the UK institutions are now offering some kind of repository for researchers to deposit data. I'm at the University of Edinburgh, in addition to being part of ResearchSpace, and you know, we are encouraged to deposit into a version of DSpace that the university runs. And that gives us the advantage that then we get a DOI and those sorts of things. But individuals are using a lot of other kind of repositories as well. And publishers are also moving into this kind of space. So their sort of repositories can become, for example, a parking place to put your data in, and different publishers will list different repositories as acceptable. However, there's been little focus on, in all of this, on going through the research process. How does the data actually flow from when you gathered it through to deposit, publication and deposit? So the work to, you know, there's repositories that people have created are somehow assuming that the data that you've generated in your research is sitting somewhere, it's accessible to you, you can easily package it up and deposit it into a repository. And actually that's quite a challenge. And that's because people aren't used to depositing data, so they don't tend to, most scientists are not thinking when they gather a data set, whether it's in the lab or out in the field somewhere, oh, I'm eventually going to have to deposit this in a repository, so I better think about how I organize it so that I can do that easily. You know, it's something you do at the end. So that means that quite often it's a lot of work to get your data into a format, into a structure that is suitable for a repository. And in the worst cases, you find your data's in some system, you know, maybe it's in a database that you've got, you know, a web front end to that you can interact with nicely, but you've got no idea how to get it out of this database. Or it's in some kind of, say, electronic lab notebook that's in a proprietary format, and you've got no way of getting it out. So that's a problem. So what we see is that you need some sort of mechanism to kind of streamline this. And we think that electronic lab notebooks are one of the answers to this kind of thing. They're suited to this function because they solve this kind of data collection problem, where people used to write things down in notebooks. If you have an electronic lab notebook, now your information is electronic. And more to the point, it's structured. So if you look across the range of tools that people use to document their work electronically, you know, some people are using things like wikis, some people are using Google Docs, some people use an electronic lab notebook like ours, and there are a variety of software tools around that people use. So some of them will encourage you to structure your data as you collect it. But that only really works if the tools are put together in the right kind of way, and we'll look at that. So currently, what happens with electronic lab notebooks typically is that we've got this electronic lab notebook, and people are busy putting data into it. But what quite often isn't available is that all the files that you also have your data in, whether they're images or spreadsheets or whatever, which are out in a whole variety of places. Maybe you put them in your lab system, maybe you put them in, the institution offers you file systems, you put them in, maybe you keep things out on various cloud services. Can you link those in to your electronic lab notebook? And some ELNs allow for that and some don't. And then the second component to this is, even if you do have these links to files, which are absolutely essential these days because nobody's typing in all the information in an experiment into their lab notebook, even if you have these links, the next question is, can you then easily take not only what is in your notebook here, but also these files, which are an essential component. Can you easily get those into repositories, whatever kind of repositories those are? So those are the challenges, and we think that ELNs, if they're set up to support these kind of links and this kind of deposit, which RSpace is, that they become much more useful as part of this whole documenting your data and publishing it. So the key is connection. The ELN, we see the ELN as a connectivity platform, so you can connect up all your data in a structured way, and you can then push it to other services like repositories or publications. So connecting to different kinds of files and exporting in a whole variety of different ways. So what we hear from most scientists is that they want export in formats that are easy to read, like PDF, or sometimes people want HTML, so web pages. Those are the two most common ones that people want. Or if it's a very small amount of information, they might want a Word document. So those are great for most of the purposes that scientists think about in our sort of everyday working lives. If I want to share something with a colleague, I can send them a PDF of the results of this experiment, or I can create a little website with the HTML pages and point them at it, and they can look at it. So that's sort of useful in itself, but the other really important aspect is being able to get data out of whatever system it's in the same structured format that it's in there. So you put a lot of work into organizing this information in your electronic lab notebook. Can you get that structure out? And that's where exporting to something like XML is necessary, because that will retain the structure that you've put in. So we've gone to quite a lot of work to make sure that all of the information people put into RSpace can be exported in a big XML archive. Now, for most scientists, that archive isn't particularly useful, because most people aren't going to go and read XML, and most people don't have the tools that they can easily use to do something with that XML. But it does mean that if you want to import it into some other system that supports structure, like another electronic lab notebook or a database, or possibly even publishers' archives if they get around to doing that, the XML can be processed and relatively easily and put into those kind of systems. So this is a key aspect of making data not only suitable for publications, but also portable, so that people can move between institutions and take their structured data with them. So we have done this for the scientists and for the ability to move between tools. We've also created links and abilities to export directly to various publishing platforms like Dataverse and Figshare and DSpace. And I'll end this with a sort of short video showing the Figshare export. So let's see, where are we? Yeah, so let me just say a little bit about linking to files. So why are files important? Well, the main reason is that a lot of the process of doing science these days involves gathering data in electronic formats. If you look at biology, for example, there's a huge amount of automatic gathering of data, especially in high throughput situations. And biology labs are becoming more and more roboticized, in fact. So the data is already in an electronic form. Images are a prime example of this. Whereas 10 years ago, it was quite common in a biology lab that you would take your Western blot image that you'd gotten on some machine, and you would print it out as a piece of paper, which you would then paste with glue into your paper notebook. So, you know, we're now kind of beyond that. And it's quite an interesting, I mean, I've been working in this area now for close to 15 years. And a lot of these changes it's a sociological phenomenon. So the younger people who are coming through the system just expect everything to be electronic now, because their whole lives, everything's been electronic. Whereas older people in my generation, in biology labs, you know, when they were PhD students, everything was on paper. When they were postdocs, everything was on paper. When they were young faculty, everything was on paper. So it's much easier, I think, now to the kind of things that we're all talking about. It's much easier to for the community, the scientific community, to be adopting them, because we have a new generation coming through. So yeah, so files are important because you've already got structure in the data. And another key thing about all these files is quite often they're huge. I mean, image data is a good example of this. You can easily have terabytes of image data related to experiments that have been done. The last thing you want to do is take them off the file system where they currently are and move them into some other piece of software like an ELN or a database, where they're just going to take up a lot more space and probably be less accessible. So with small files, you can think about doing that, thumbnail images, you know, but those aren't typically what people want. Sequence data, for example, is huge. So it's not practical in many cases, and it's even less desirable to put it into the ELN. But it has to be part of it. So the way to solve that is to make it easy to make links. And most ELNs don't actually support this at the moment, although I think people are beginning to recognize it, so that there is work in other systems. So in RSpace, various institutions that where we have users are doing this kind of linking. So the most common sort of linking is either to lab file stores, and we're pretty much focused on lab science. And in some institutions where there's an institution-wide file system, for example, at Edinburgh and at Manchester, those are two examples where there is an institution, university-wide file system provided for research data, and increasingly scientists are using it. So we have links to those kind of systems. And then we also facilitate links out to cloud systems, which certainly in the US, there are quite a lot of universities that are using Box for research data. And of course, we also support just uploading and linking of data from people's computers. Now, one thing about this linking, one of the really important things about linking to files is, you know, this system that we provide has control of the data that's in the system. So we can guarantee that it's not going to become corrupt. And if you make a link from one thing in RSpace to another thing in RSpace, that link will always be valid. We can guarantee all of that. Once we start linking out to these systems, we can't guarantee it anymore. If somebody has a file out on their institutional data storage and they move it to a different place, how does RSpace know about that? It doesn't. If they move it from Google Drive to Box, you know, how does RSpace know? It doesn't. So this is a really big, it's not a problem initially, but when a lab upgrades its file servers, it suddenly 3 years worth of data and all the links are broken. That can be a problem. So we have in the past had various workarounds for this and guidance to labs as to how to deal with it. But we now have a new solution, which we're trialing with at Harvard Medical School later this year, well, quite soon actually, with a company called Starfish. And what Starfish do is they essentially sit on top of all of these different file systems, and they provide a unique fingerprint. It's a bit like a DOI for the file that's guaranteed to be permanent and permanently traceable. So then RSpace can just talk to the Starfish system and say, and just retain those essentially DOI. They're not DOIs, but they're like that. They're an identifier. And RSpace can go through the Starfish system to be able to find files, even if they get moved around. Okay, so that's, let's see, how much time do I have? 2 minutes. Okay, I'm going to run through the rest of it. So the other part of this is exporting. So we think of ourselves as operating as it says here, as a conduit rather than a silo. So once you put something in, it's very important to be able to get it out. And there's data export in lots of different formats and with lots of different kinds of control. So you can export the whole lab's work, you can export all of your work, you can export particular kinds of work, and you can associate ORCID IDs with those exports. And we've integrated, as I said, with various kinds of archives to make it easy for researchers to make those deposits with just a few clicks within RSpace. So these are some of the logos of some of the different kinds of repositories that we work with. So I'm just going to finish after this with a very short video showing you, 2-minute video showing you the deposits to Figshare. But these are contact points. Okay, let's see if this will work. Maybe not. How do I do that?
As of version 1.41, RSpace is excited to announce its new integration with Figshare. If you're not familiar with Figshare, it's an online digital repository where researchers can preserve and share research outputs, including figures, data.
Okay, thanks very much, Nigel. We've got maybe 1 minute for a quick question if anyone has one. If not, Nigel, I think you'll be around at the end where people can ask you questions. And I should also say that we are kind of really interested in electronic lab notebooks at the moment at Cambridge, and we're hoping to pilot some in the near future. So if you're interested, we've got an email list that you can sign up to where you can sort of find out about these trials when they start in the sort of hopefully coming months. So thank you very much. So